Okay, thanks, Kev. I will share my screen right from the start because otherwise I'll forget to do so. So really good to see the code of conduct there highlighted. I gave a similar talk a year or so ago, and people started drawing over the screen, and they weren't the kind of useful drawings that you might expect. Hopefully that won't happen today. If it does, we will just turn off screen sharing and you'll have to look at my face instead, which will be sad for everyone, I think. So today, the title of the talk is Storing UTC is Not a Silver Bullet, but that's sort of the second half of it. This was inspired by a talk, by a blog post that I wrote that Sakis saw around my EV charger. That again is in the second half of the talk. So we're going to start off by looking at date and time stuff in general and how I think about dates and times, and a few messages around it's not so bad really, but it can feel awful. So we'll go into some concepts. These are all very much around Noda Time, which, if you're not familiar with Noda Time, it's the library that I'm the primary maintainer for, which is an alternative date and time API for .NET. It was originally sort of based on the engine of Joda Time in Java, but with a new API, because there were various things in Joda Time that felt like they weren't quite right and obviously didn't feel right for C#. And so it was a new API on top of the Joda Time engine, and then I replaced the engine out at the bottom as well. So it still resembles Joda Time. If you're familiar with Joda Time or the java.time library, you would be familiar with Noda Time, but many people are really only familiar with DateTime and DateTime offset, and maybe now date only and time only, which I think are still insufficient for what you need when working with date and time information within programming. So we'll go into the concepts that I think are important and that we provide in Noda Time. Then we'll take any questions around that. We'll break for 10 minutes to raffle off the JetBrains stuff. And so my guess is that I'm aiming for finishing the first half by 7:15. I will fail to do that because I've done a slightly longer version of this talk before that's an hour long, not 25 minutes. But we'll see where we get to. Then after the break, we'll get into the actual title of the talk, why the advice that you always hear of, just store everything in UTC and that will solve all the time zone issues. No, you actually need to think. And if you think, everything will be okay. And you may come to the conclusion, hey, what I should do is store things in UTC. And that's fine. Or you may think and say, actually, that would be a really bad idea because of X, Y, Z. And I will give two examples, one about events in the future and one about charging an electric vehicle, and then just give a few general dates and time handling tips. And then hopefully we'll be wrapping up around 8 after any final questions. So I'm going to be rattling through this at speed, which means that you may want to refer to the video afterwards. That's all fine. If you put questions in the chat, I may or may not see them. I do now have the chat window up, but I can't guarantee that I'll pay full attention to it. We'll see how we go. So what I will not be covering today is relativity or leap seconds. These are both horrible concepts. Leap seconds hopefully will be a legacy concept at some point. I really like the idea of every minute being exactly 60 seconds. Noda Time does not try to model leap seconds. A few date and time APIs do. It makes everything much more painful, and very few programmers need to worry about leap seconds. If you are dealing with GPS, you may well care about leap seconds. You may also then care about relativity. If you are writing a line of business application, I contend you don't need to care about either of these things. And I suspect that very few Noda Time users are writing things that deal with GPS. So there are specialist times when you need to care about these. Let's not for the moment, because our brains will hurt enough anyway. Speaking of which, so There are generally two reactions that developers have to, I've got to deal with some date and time stuff now. Either it's this, which is typically the reaction of an experienced developer, or it's, this is fine. I'll just write some code, and I might write a couple of tests, and then if those pass, everything must be fine. And of course, the middle ground is neither in, eek, this is completely impossible, I will never get my head around this, nor is it in, oh, I don't really need to think about it too hard. If it compiles, I'm sure it'll work. The reality is, if you get your head around the concepts of date and times, then most problems are reasonably solvable, particularly if you can make sure everyone on your team has the same concepts, and vitally, your product manager or whoever it is who writes the requirements uses the same concepts, uses the same names for the concepts, and can be persuaded to write detailed specifications that are actually clear and unambiguous. That is probably the biggest challenge. A book that I wrote recently with another author, Software Mistakes and Trade-offs. In fact, yes. So with Thomas Lelek, this goes into dates and time. I've got a whole chapter on it, and I give one concrete example of, product manager says, oh, people should be able to get a refund for their product within 3 months of the purchase. Like, okay, let's tear down that requirement and be really specific. 3 months in what time zone, from what exact time, what happens if 3 months from, like, whatever it is, November the 30th, is that February 28th, 29th, or March 1st? That sort of thing. If you get precise requirements that you can easily write tests for, then most of the time, the actual coding isn't too bad. I've got a counter example later on when I tried to write code to handle my own situation and found that there were just so many corner cases that I couldn't be bothered to do it. It was basically for this talk, and I'm not going to spend an entire day writing a load of corner cases. It would have been solvable eventually, but it would not have been fun to do. But it is feasible. Pay attention to, not pay attention to me, pay attention to the concepts in your domain and your product, and it is feasible. I would strongly encourage you to just take the time to pursue this carefully. Now, I've mentioned the concepts several times, and here is a list. This is not the complete list of types within Noda Time, but these are the most important ones. And it is overwhelming if you're used to system.datetime and maybe system.datetime offset, and let's be really radical and also use system.timespan. This can look, well, why would we have all of these types? Much as if you look at the C# set of numeric types, so byte, sbyte, short, ushort, int, uint, long, ulong, decimal, float, double. If you were a JavaScript developer who was used to just, well, I've got numbers, then they're always 64-bit floating point. Why do I need an integer type? Why do I need different lengths of integer types? This is pointless. I'll just use my number. Much the same kind of reaction. But I suspect most people, if someone suggested that C# should only have one numeric type, most people would say that was a bad idea. For some reason, date and time libraries often, the system date and time libraries tend to be rubbish, and they try to crystallize down to, we only need a couple of concepts. The more concepts you have, the more precise you can be with what you're allowed to do with different things. So let's dive straight in. First concept is an instant in time. Now, the first, I think, 3 concepts I've got are all in what I call machine time, which is, we don't care about you pesky humans. We also don't care about relativity, but we will just have the concept of an instant in time, and it is global. Every machine on the planet will agree what instant now is. We have no concept of your human cultures. We have no concept of time zones. It's just an instant in time. And typically that is represented internally as an amount of elapsed time from some epoch. Now, hopefully, the library you're using will mostly shield you from caring what epoch you're using, but you can think of epoch as a little bit like sea level. You know, if you're trying to say how high is a hill, you say how high it is from sea level, because you've got to have some sort of baseline, some 0 point, and that's your epoch. There are multiple different epochs in use. The most commonly used one probably is the Unix epoch, which is 1st of January, midnight, UTC in 1970. Now, if you just heard me say, oh, we don't care about your human concepts of culture and calendars and time zones, why am I saying 1970? Like, that assumes in this case, Gregorian calendar in UTC. Well, that's sort of like a time zone. Well, because the way that humans communicate tends to be with all of those things, but the instant of that Unix epoch, I could also have said it's I could have said it was the time that the instant at 1 a.m. in January the 1st, 1970 in Greenwich, which might confuse you because you'd expect the UK to be on standard time in the 1st of January. Well, between, I think it was 1969 and 1962, we were actually in BST, which was British Standard Time. So it was standard time, but it was still UTC +1. Confusing stuff. But the same instant can be described in multiple ways. You could have said it was, I guess, 7 p.m. on December 31st, 1969 in New York. Same instant in time, described in multiple ways, same epoch. So we've got the idea of an instant in time. If we're representing it with an elapsed time, then that feels like that should be a concept as well. And indeed it is. So a duration is just a very clearly defined amount of time in whatever precision you've got. So in Noda time, it's nanoseconds. Effectively, it's how many nanoseconds have you got? So 100 nanoseconds is a duration. 1 minute is a duration. You can tell how many nanoseconds are in it. And this is where it's important that we don't include leap seconds in this. Is a day a duration? Well, if we assume a 24-hour day, then yes. It's not necessarily, you can't talk about a duration between 1 o'clock in the morning today and 1 o'clock in the morning tomorrow, because that could be 25 hours, 23 hours, 24 hours, or even weirder amounts for some odd time zones. But a fixed amount of time, and two durations that are the same amount of time, doesn't matter when they occurred, the duration itself has no concept of when it occurred. So 10 nanoseconds that happened back in 1900 is still the same length of time as 10 nanoseconds happening now. Just as if you think of a length, 5 centimeters doesn't matter whether it's here in my shed or wherever you are. Compare that with an interval, and this is the last of the fundamental concepts for machine time. And this is literally just, it's a start point and an end point. So it has a duration, which is the end minus the start, what's the difference between them? But it's just 2 instants in time, and 2 intervals that don't have the same start and end time, even if they have the same duration, they are not equal. So it's sort of like a vector with an origin, a specific origin. Those are the machine types. They're relatively simple to think about because they're oriented at machine ideas of time. Now we move on to stuff that gets much more confusing. We start bringing humans into the picture. So here is a calendar system, which in Joda time or Java.time would be called a chronology. So a calendar system, the point of it is to divide up the sequence of days, and I won't say intervals because this is all leaving time zones aside for the moment, but a sequence of days into years, months, and days within the month. So I mentioned the Gregorian calendar system before. That's the one we're generally all used to. It is closely related to the Julian calendar system, which only differs in terms of how leap years are organized. If you're aware of when we sort of skipped 13 days or however many it was in September of, I want to say 1752, but I'm probably wrong. That was moving from using the Julian calendar system to the Gregorian calendar system. There are many other calendar systems, and if someone ever asks you what the relationship between religion and computing is, it's calendars. It is the single place where we get the most influence from calendar system. Sorry, from religion. Pope Gregory. That's where we get Gregorian calendar system from, and you can even look at the UUID timestamp bit has an epoch that was related to when the Julian calendar system to the Gregorian calendar system flip happened in Rome because of Pope Gregory. And all the other calendar systems that I'm aware of are to do with religion. So there are various Islamic calendar systems, various Hebrew calendar systems to do with Judaism, or one main one with sort of two variations on it. All kinds of things, because religion and celebrating different festivals, etc., very clearly tied to working out dates. So a calendar system breaks up set of days into years, months, and days. And most of your software probably is fine to assume the Gregorian calendar system. Just be aware that you're making that assumption. If you are trying to write something for consumers who are in all kinds of countries, then you might want to consider, are they all using the Gregorian calendar system? Do they maybe use the Gregorian calendar system for business, but maybe if they're doing personal things, they might use a different local calendar system? Do you need to support that? I can't answer that. Your product manager needs to. So within a calendar system, we have the idea of a date. Again, we haven't got any time zones going on. We've just got the date. So today is March the 15th, 2023 in the Gregorian calendar. And if I ask someone in the US who might think that it's a different time of day, they would still say it's March 15th. At the moment in Australia, it's March 16th. But we can still, so we might not agree on what the current date is, but we can agree on the concept of a date. And for example, people generally have a birthday, which is a date, the date on which they were born, and they will celebrate their birthday wherever they are in the world when that month and day occurs, regardless of whether actually at the place of their birth, the date has changed. So that's just a local date. And I'm aware that the terminology of local here can be confusing. It's local because it doesn't refer, it's not scoped by any particular time zone. It's, well, in my local area, it is now March 15th. And this was also copied from Noda Time. I couldn't come up with any better name, but it does cause some confusion. Similar to a date, we have a time of day. So .NET uses time span. If you have DateTime time of day is a time span. And time span itself is very close to duration. But they shouldn't have used time span for time of day. And these days you would use time only. So if you're familiar with system.time only as of .NET 6, I think, it is a local time. And likewise, local date is date only. The reason why time span was a bad idea is time span is meant to measure an elapsed amount of time, and you don't know the elapsed amount of time since midnight because there could be some time zone changes going on, etc. So it's just a time of day. There's an interesting question here as to whether 24 o'clock should be a valid local time. It can be useful to represent. We do not allow it in Noda Time. we do allow parsing some text fields with 24 o'clock, and we just say, oh, that's midnight the next day, which is better than nothing, not potentially ideal, but you have to balance, how do I make things work reasonably for the people who do need this without making things much more confusing for others who don't. Okay, just to say, I'm aware. Oh yeah, and as noted in chat, yes, the Gregorian calendar was indeed introduced in different years in different countries just to make it fun. It's much worse than that, in fact. Sweden tried to introduce the Gregorian calendar in a slightly different way to other countries. They tried to do like leap smearing over it. They said, well, we won't have any leap years for as long as it takes to go from the Julian calendar to the Gregorian calendar. So I think it was in, I could get the years wrong here, I think they deliberately didn't have a leap year in 1804, but then they were involved in a war and they forgot their plan, so they accidentally had a leap year in 1808, at which point they were one day out from where they should have been, and they decided, oh, no, blow it, let's just go back to where we were. So in 1812, they had a double leap year, so February the 30th happened in Sweden in 1812, in order to get back to the Julian calendar system, and then they did a flip over, let's skip a bunch of days later on, but it was an interesting little experiment. So yeah, some APIs try to model cutovers between the Gregorian and Julian calendar systems. Noda Time, we tried that and couldn't get to anything that gave a nice consistent way of doing things, and we figured most people aren't going to care. So if you need cutovers, it's hard. Yeah, it is. Date and time stuff has a just fabulous degree of trivia. And in fact, if you go to https://nodatime.org/trivia, is that, let me just check whether I need a I really want to get this link into the chat because it is such a good I realize I should possibly only do this right at the end of the session, but have a look at that later on, and there's so much fun stuff. Like, who'd have thought that our tax system would be affected by all of this? Why do you think our tax years start on April the 6th? Well, the answer is in the page. Okay, so moving on, I've got 6 minutes left to do the remaining concepts. A date and time is a date and a time. Local date time, what we call it. That's one of the concepts that you will use frequently, and that's kind of all there is to say about it. It's made of those two bits. Now, what everyone's been sort of dreading is time zones. So let's start off with things that are not time zones. UTC +2, for example, is not a time zone, despite what ISO 8601 says. That is a UTC offset. And basically, UTC is like the 0 point, like an epoch, but for time zones. And we measure how far away we are from UTC. So currently, we're at UTC +0. Next week will be UTC +1. Neither of those is our time zone. We are currently in the Europe/London time zone, using the IANA time zone ID. And a time zone is a region of the Earth where people's watches, assuming they're accurate, all say the same thing. Okay, so at any given instant in time, everywhere within a time zone has the same UTC offset. So when our clocks go forward on Sunday, we are not changing time zone. Our time zone is changing UTC offset. The UTC offset for everyone within the Europe-London time zone, so the region of the Earth that is covered by Europe-London, their offset changes to UTC +1. And it's really important to understand that. So something like GMT, okay, GMT is a bad example because it's sort of half used as a synonym for UTC, which is also not really a time zone, but we often consider it as one. But BST, British Summertime, is not a time zone because, well, where would BST cover? Well, if it's the same area as Europe, London, but BST we only think of as UTC +1, right? It's not, it doesn't apply all the time. It's a sort of half time zone. So all of these 3-letter acronyms, leaving aside the fact that there are about 5 different places that are called CST, and just never use the 3-letter abbreviations if you can help it. Leaving those that aside, they are not time zones, whereas Europe, London, or America / Los Angeles, etc. These are IDs for time zones. And the idea is a time zone you can always find the offset from UTC given an instant, which means you can find out what the local date and time is. Remember local date time? So at any given instant, there is exactly one local date time per time zone. It is a function from instant to local date time, or a function from instant to offset, they're equivalent. Assuming a calendar system, admittedly. You can't do the reverse in a predictable way or a uniform way. So given a local date time, there may be 0, 1, or 2 mapping instants. So if I say 7:13 in Europe, London on 15th of March 2023, there's only one instance of time that will happen on. That's all fine. And I'm just, before I start saying this multiple times, I'm going to check that the clocks really do go forward in London this weekend rather than next weekend, because that would be a real shame to be on video talking nonsense for the whole time. No, it's a week on Sunday, on the 26th of March. So today, 7:13 p.m, Europe, London, there is exactly one instant. On the 26th of March, 1:30 in the morning, the local time of 2023-03-26 T 0130 has 0 mappings to an instant. There are no instants in Europe, London, where that is the local date and time, because we skip from 1 o'clock in the morning to 2 o'clock in the morning. So that's a skipped transition. In October, and I had it up, but I can't remember it now, the date in October when we fall back, at 1:30 in the morning on that particular Sunday morning, there will be 2 instants, because you go through it first time, and you hit 1:30 and say, oh yeah, that's the instant that I mean. And then time continues. And at 2 o'clock, you go back to 1 o'clock and you hit 1:30 again and say, oh, but there's also this second instant. And if you look at the graph that I've got here, that's because if you try to, mapping from a local date and time to an instant is taking a horizontal line from the local date time, and where there's a spring forward, you can end up missing the line entirely, and when there's a fall back, you can end up hitting the line twice. So be very, very careful anytime you've got a local date and time, which is often something that the user's given you, and you're trying to work out what instant in time is represented. Be aware there can be ambiguity, or it could be skipped. Okay, and it is now 7:15. So we're very, very nearly there. So once you've got the idea of a time zone and an instant, you put them together and you get a zone date time. But it's also with a calendar system, and that tells you what everyone's watch will say, basically, within that time zone. So at a given instant, everyone in the whole of the Europe-London time zone, their watch should show the same date and time, assuming they're all using the Gregorian calendar as well. And what they're showing, that is the zoned date time. Another way you can look at it, if you don't care which time zone they're actually in, and just what the UTC offset is to have an offset date time. Because this doesn't know what time zone it was in, I can't tell you what the local time will be 1 minute later than this, because maybe there's a transition at halfway through the minute starting at 9 o'clock. And so 1 minute later could be 10:01, or it might be 8:01. It seems unlikely. That would be a really weird time to have a time zone transition, but it's possible. Offset date time is what you get in ISO 8601 formatting, because it doesn't really have a time zone ID. So you will see this in this format in multiple places. Just be aware of it. And finally, before we break for any questions before the break, a period of time, in contrast to duration, a period is how you measure time between calendrical things. So in this particular case, it's 2 dates. So this is 1 month, even though we don't end up with the same day of month afterwards. And different APIs will have different ways of handling this sort of situation. But if you want to say, how old am I in years, or years, months, and days, then you're asking for a period. And in Java.time, a period only goes as far as days. In Noda Time, a period can be, give me a period of 1 month, 12 days, and 52 hours. And it allows you to represent that, and it will apply the different units one at a time. And you can subtract 2 local date times, one from the other, and say, give me the difference between, when I was born and when it is now in years, months, days, hours, seconds, for example. Those are all the concepts that I have. I fully expect people to have to look back on the video in order to get your head around it. I would encourage you to have half your screen with a video and half your screen with your product requirements, and try to see, that thing there, that's a log timestamp, or maybe a commit timestamp. That's probably an instant. That there that I've got as the predicted delivery date, that would be a local date. Some chat message, you might have a local date time. There's all kinds of differences. But if you look at real world data and try to work out what concept maps to it, I think you'll get a closer idea of what I'm waffling on about. So before I hand over to Kev, any final questions before we go to the break and I take a big drink of water and a Strepsil? The second half is going to be much less dry, and will hopefully also make you go, what? What? A bit more. Right, let's go back to talking about UTC. So UTC is useful. I'm not going to deny that for a second. And if you're going to store a date and time in a database, or a value in a database, if it is an instant, then storing the UTC instant, converting that instant into a UTC in the Gregorian calendar and storing that is a perfectly good way of doing it. Or storing the number of seconds since an epoch, storing something that is machine time, effectively. When people say store UTC, they really mean store something that represents an instant in time, potentially by converting a local time into UTC to start with. That's great if you're trying to store an instant in time, but it's not in other cases. And I've got 2 examples here, and we may well take about 10 minutes on each of them, and I'll ask for any questions on each of them as we go as well. So suppose back in January 2020, can you remember that? Before, when we might have just about heard of COVID, but didn't think that we were heading for lockdowns. Suppose we were going to try to book a meeting for today with the UK Prime Minister on March 15th, 2023, 7 p.m. at the Department of Digital, Culture, Media and Sport. Okay, so this is something that a calendar system, as in a calendar application, a user might want to do this. And there are 2 options that we have here. We can either try to normalize what the user has told us at the point at which we create the event. So this is what happens if we do that. We're going to meet with Boris Johnson on the instant of 2023 0315 T 1900 Z, if you're not familiar with that sort of block of text in the middle, that is an ISO 8601 representation with Z meaning in UTC. And we're going to meet at this Latin long. Okay, so just to remind you, that was what the user told us. And one option is to say, well, who is the current UK Prime Minister? That's who we're meeting with. What do I predict the instant of March 15th, 2023, 7 p.m. in London will be? And where is the Department of Digital Culture, Media and Sport? Okay, so imagine that's what we stored in the database. The second option is to instead store what the user told us. So we say we're going to meet with the UK Prime Minister. We're going to meet at, this looks basically the same string. I haven't put seconds on, but it's basically the same string, but knowing that it's the local time for wherever we're going to meet. And we're going to meet at the Department of Digital Culture, Media and Sport. So how many things have gone wrong here? Well, now you can argue amongst yourselves as to whether Boris Johnson is no longer the Prime Minister is something that's gone wrong or not. Okay. But certainly from the perspective of I was going to meet the UK Prime Minister, I was expecting Boris Johnson, I get Rishi Sunak instead. That is the application failing. If we store we'll meet with the UK Prime Minister, we can re-normalize whenever we need to. So in the meantime, maybe if you looked at your calendar, blink and you miss it sometime last year, you'd have seen you're going to meet with Liz Truss. And then later on, you'd see you were going to meet with Rishi Sunak. When you look at your calendar in the morning to see what's my day looking like today, I'm going to meet with Rishi Sunak. Now, if we stored Department of Digital Culture, Media and Sport, well, in a recent cabinet reshuffle, that department got split and merged and changed. In option 1, we specified the precise location, the Latin long. I don't know whether they're still based there. The right bit of what used to be the Department of Digital Culture, Media and Sport. So we definitely have somewhere to go, but we don't know whether it's right. In option 2, we've stored something that no longer exists, so we can't actually tell the user where they're going to go, but we know what they told us, and we know we can find out that it's no longer valid. And the user can say, oh yeah, well, it turns out that I'm going to meet in the culture, media and sport bit, which I think is now a department and digital went into business or something. I don't know. But we know that we're lacking information at that point because we know what we were told and that information no longer makes sense. We know that it no longer makes sense. We don't confidently go to the wrong place. And if this all sounds a little bit ChatGPT like, there's a relationship here, know what you know and what you don't know. So that's who and where. What about the time? As it happens, what we stored in option 1 was correct, but only because it so happened that there wasn't any legislation, which easily could have happened to change the UK time zone, not to change it to a different time zone, but to change what the rules of that time zone were. We could easily have had some legislation in 2021 saying, as of June 2022, the Europe-London time zone will be at UTC +1 the whole time. In which case, if you turned up at that normalized stored UTC value, you would be an hour late. Okay. So basically the moral is, if you store what the user told you and normalize things just in time, and you can do that as often as you need to, and maybe you normalize and store things for optimization purposes. If you want to see a list of events in order according to what I currently believe, then normalizing and storing that, great. But store the original thing as well. Jonathan asked a good question. Whose local time? Yours, the Prime Minister's, or the location's local time? That's a product question, but I would normally say the location's local time. if I arrange a meeting with Emmanuel Macron, as I often do, in New York at 5 p.m. next Friday, as it happens, it wouldn't be. I'm busy next Friday. He'll have to find another time. But if I'd arranged that, I would expect, well, we're meeting in New York. I expect it to be 5 p.m. in New York. And while I'm in the UK, that might show in my calendar system slightly differently, my calendar application slightly differently. But given that a time zone is related to a location, I expect the time zone for an event to be related to that location rather than that person. I guess it's possible a cruise ship. I've no idea. Ask your product manager. This is my point. Ask your product manager. I know fans of the West Wing will remember a bank of clocks where POTUS has his own time zone almost. The president of the United States. So this is one place where if you store UTC, you can go wrong because rules can change, and it can be really hard to get this across to people. When you say the rules for a time zone can change, they say, yeah, we know that. We know it skips forward in spring and falls back in the autumn. We know that. We can handle that. It's like, no. That's one set of rules. We can change the rules so that it doesn't skip anymore, or it skips twice, or does all kinds of things. It's a different sort of level of skipping. Level of rule changing. I have a blog post about this. If you search for "storing UTC is not a silver bullet," because I am nothing if not consistent, but not imaginative, you will find a blog post that goes into all of this in much more detail. You will also find the comments of people who say, oh, this isn't a problem because XYZ. And then after a bit of a conversation, they will say, well, yes, it's a problem if you store something in the future and the time zone rules change. It's like, what's the premise of this blog post? That's exactly the premise that I'm worried about. And if you're not writing something that stores things in the future, or you are so supremely confident that laws can never change between now and then yeah, you're okay. But in general, I would say the lesson here is it's better to store what the user says. So I'll pause for a few minutes for any questions on that first scenario, because the other one is somewhat different. No? Okay. I will note that this just store UTC is really, really prevalent. How do you store the time if it's not the actual time? You store the local date time. I gave an example. And if you're storing it in a database, that's a whole other area of problem. Is what database documentation you would expect to be really precise around how they handle data. My experience is it's just not. But if you store, whether it's a string, saying store 2023-03-15 T19, that would be fine to store, and that is the local date and time. Maybe your database or whatever data structure you're storing it in has this as a sort of natively supported data type. I don't know. But if you're doing a time zone conversion from a local date and time to UTC, then please be aware that you are doing so by following rules that might have changed by the time that thing actually happens. If it's in the past, you're probably okay, but you still need to worry that actually you might be trying to do a conversion on something that was ambiguous. Have I come across this issue in reality or just hypothetically? Well, as it happens, the next scenario is a real one. As I say, it's slightly different. I have worked with the calendar team. I'm aware of when rules change. I honestly don't know how Google Calendar does store things internally, but knowing that rules can change, if you are in, I think it was Iran that I mentioned earlier on that gave 1 day's notice. Well, I think it's not inconceivable that people in Iran might plan an event for next week. I don't know. My guess is that half the applications got it right and half the applications got it wrong. So while I haven't personally experienced this because the UK hasn't changed its time zone rules since 1972, I think. I think it is definitely a real issue, and it also speaks more to a more general thing of remembering what information the user entered rather than trying to normalize too early. Facility opening times for warm banks. Yeah. Don't have to open in July. Yes. Eek. Okay, so the second scenario was started by me tweeting, and this, I don't use Twitter much these days anyway, but I was interested. I have an electric car, a Volkswagen ID4, if anyone's interested. I'm very pleased with it. I'm on Octopus Go as my energy supplier, and Octopus is the supplier. Octopus Go is the scheme I'm on, which gives me cheap electricity between midnight and 4:30 in the morning. So my car charger, which is a PodPoint, allows me to set for, and its user interface isn't great, I've given them feedback on that, but it allows me to set a schedule of when it will turn on. And I have every day set to be midnight till 4:30 in the morning. And if I ever need to charge during the day at expensive rates, relatively expensive rates, then I have to go in and change my settings. Fine. Okay. So last October, I tweeted saying, oh, this is really exciting because the clocks go back. They'll go back from 2 in the morning to 1 in the morning, which means the bit of time between my local midnight 30 and my local 4:30 is actually 5 hours long. I wonder what will happen. And spoilers, it did give me 5 hours of charging. I actually needed to charge the car that night as well. So this was just a sort of me saying, oh, isn't this interesting? It was the internet. I got replies. To avoid issues like this, most programmers convert all times to UTC in the back end, and that's also the default server embedded controller OS setup. The only place you use local time is displaying or to allowing entry by the end user. Nope. Second, if the charger is connected to the internet and is sharing info, then it should only do so using UTC. Because we can't afford to think as developers. We must just accept the mantra that we have been given by other people that we use UTC for everything. If you come up with any problems when using UTC, it must be you that's wrong, not the mantra. I'm super interested in this, but I feel like they'll just do watts over seconds from epoch and it'll all come out in the wash, which is effectively a slightly different way of saying, oh, it'll use UTC. Fortunately, not only are they wrong about how the system works, but they're also wrong about whether UTC is the right thing to do here. Before we go into how that all works, I got a couple of other replies as well, which I think have an interesting moral to them. Clocks don't go back until next weekend, though, and I should do that in what I believe was a US accent. And where do you live that the clocks changed today? I can't imagine that anyone else lives in a different time zone to me. My Twitter profile says I live in Reading in the UK. Okay, he was one click away from finding out that information. And just stating clocks don't go back until next weekend. Try to get a bit of perspective that maybe not everyone's experience is the same. Like saying, I don't think there's any risk to women walking late at night because I walk late at night and I don't feel scared. Maybe not everyone experiences the world the same way that you do. Yeah. Moving on, but please remember that. Let's all try to get some perspective, and I'm saying that to myself as much as to anyone else. Okay, so having had those replies all saying, oh, you should use UTC, and there were various other replies as well, but there were quite a few saying use UTC. The first question is, right, well, if you're going to convert everything to UTC, what are you storing? all I'm putting in my application that only shows times of day and the day of week on which it's going to be applied, I get a start time and an end time. These are times of day. You do know what time zone the charger is in, which may not be the same time zone that I am physically in when I'm using the application. But leaving that aside, let's assume the time zone is the one for the charger. Well, what is the UTC offset for 4:30 in the morning? Well, ask me today and I'll say 0. Ask me in 2 weeks' time and I'll say 1. So are you going to store in your database? Well, what date are you going to use, for one thing? Are you going to store January the 1st 1 CE at 0330, 0430, something else? If I were in the United States entering exactly the same information, would you store something different? Or maybe you haven't actually got a date and time in a time zone, so the idea of converting that to UTC is a nonsense to start with. So I don't know what you're storing and what you're sending across the wire. If you're saying all communication must be done in UTC, what you're saying makes no sense. It's like saying you should only ever send English across the wire. English words, please. Right. Now send this music song. Like, okay, but it's got music in it. It's not just words. I don't care. Convert it all into words. Describe it in terms of there is a cello playing the C below middle C, and then it's just nonsense. If you've got the right data types, you can see it's nonsense immediately, because in order to convert it into UTC, you have to give extra information you don't have. So, leaving the storage part aside, I tried to implement this. And so I had a scheduler. The schedule just had a day of week, 7 entries, each of which for one day of the week, knew which day of the week it was for, had a start time and an end time, both of which were the local time type, because obviously I did this using Noda Time. And once you've got that, you've got a schedule, and you can say, given a local date time, I don't care what time zone you're in, but give me a date and time, and I can tell you whether the charger should be on. Because that's all that the application is telling me. Like, for this day of the week, between these local times, it should be on, and all the rest of the time, it should be off. I don't care what time zone you're in. I don't need to know that. I just need to know what date it is, and therefore day of week, or even just what day of week it is, and what the local time is. If you have some weird clock, maybe you've got a video a webcam pointing at a grandfather clock and a calendar next to it, and that gives you the date and the time. I don't care what time zone it is. But you can consult the schedule and say, should I be on or not? Make the charger, turn it on or off, and then go back to sleep. Literally, in my sample code for this, it has thread.sleep 60,000 or thread.sleep timespan from minutes 1, something like that. I can check once a minute. I could be off for 59 seconds longer than I should be, or on for 59 seconds longer than I should be. That's probably fine. Make it a shorter sleep if you want to. It will take a bit more power. This is, an embedded system. You probably want reasonably low power. On the other hand, the power taken by the controller chip for this, compared with the amount of power you're going to divert into a car, is really, 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 really small. Anyway, I was having a look at this today, the code for this, which is all on my GitHub repo, which I'll put in the chat, github.com/jskeet/demo code for people watching on a video, under EV charging time, I think it is. And I've got lots of comments, but I think there's about 40 lines of actual code in there. And most of it is just setting up a separate class for the schedule and things like that. Really, really simple. However, when Sakis approached me for this talk, I was like, okay, well, what's the alternative to this? What what's the nicer thing that doesn't involve sleeping and recalculating once a second or once a minute? So I tried to implement it, thinking, okay, given what time it is right now, for whatever reason we've woken up, if we know the state of the charger and we know the schedule, how long should we sleep for until we next need to change things? Like, predict when I will next change the state. Let's leave the fact that we need to be able to wake up as well, because we might have said, well, I'm going to start charging at 4 a.m. on Sunday, but then it's currently Monday, and on Wednesday the time zone rules change because there was an emergency session of Parliament, and they've said, in solidarity with Ukraine, the whole of Europe and the UK is adopting the same time zone as Ukraine from Sunday. Okay, fine. Well, we need to be able to wake up at that point. Well, we need to be told that that's happening and wake up so that we can adjust when we're going to turn the car charger on. Or maybe, and you might think this is a more plausible scenario, possibly the user decides to change the schedule. Maybe they want to charge the car now, for example. Or possibly we've got a system clock, but it might be checking the internet because it's not terribly accurate and it sometimes needs to go back a bit, etc. So there are reasons we might need to wake up. But then we just need to go into this loop again and say, right, well, what should the current state be? Make it so. How long do I need to sleep for? The trouble is, it's really, really hard. Okay, it sounds simple to predict when is the state next changing, but it's really nasty, because my mind immediately goes to all the corner cases, which are typically around time zone transitions. And even leaving aside large changes due to legislation or whatever, even the predictable changes are nasty. So you could have a charging schedule that goes from midnight 45 to 1:15 in the morning, but that particular day, that Sunday in October, you go midnight 31, 1:30, 2 in the morning becomes 1 o'clock in the morning again. So at that point, you want to be charging for the first half hour of 45 till 1:15. And then at 2 o'clock, it goes back to 1 o'clock in the morning. And then you have another quarter of an hour of charging. So if you were to wake up at 1:30 the first time, you've got to predict, okay, well, I need to wake up in half an hour because it's going to be 1 o'clock again. Now, 1 o'clock isn't anywhere in that charging schedule. We've got midnight 45 and 1:15. So you've got to work out, well, 1:15 happens twice, and it's already happened once. So I'm thinking about the future 1:15, the next 1:15 to happen. But actually, because I was turning on at midnight 45, I need to go when that transition happens. So that would be one painful thing to do. The other is trying to work out, I'm off at the moment, or maybe I'm on at the moment, and the charging schedule says 1:15 to 1:45, but this is a spring forward day, so actually that entire period gets skipped. So we shouldn't turn it on at all. But if you decide to implement this by saying, well, I'm off, so I'll only look at start times because I've got to transition to an on, well, the 1:15 is skipped. But let's just say, well, that means it's effective from the point of that transition, when it goes from 1 till 2 in the morning, which is what you would want if you were charging from 1:15 until 5 in the morning, for example. But in this case, you'd miss the fact that you were also skipping when you turn it off. Can you see how this is really, really hard? There is a way of doing it more easily, though. And you're going to hate this. I'll tell you this now. You will really hate this. Again, we've got the idea of, we wake up for some reason. We work out whether the charger should be on. We make it so, and we still, the same approach here of, given the current time, the current state and the schedule, work out how long I need to sleep for. Instead of trying to predict it based on, I will work out when this happens and when that happens, how about we start from now and say, in now plus 1 minute, should I be on or off? And is that the same as what it is now? How about now plus 2 minutes? How about now plus 3 minutes, etc. And you keep going for a week. We've got a weekly schedule, so maybe go for 8 days. Have a loop that checks every minute for the next 8 days until it finds a change of state. And that's how long you need to sleep for. And if you don't find any state changes, then sleep for a day and then check again. That is massively, massively inefficient. Maybe you only need to change, every 5 minutes or something. Depends on the application. But you're still only going to loop, even if it's like 60 times. How many? There are 1,440 minutes in a day. If we say, well, we'll check for 8 days worth just in case there's a Samoa type situation, who knows, then you're checking 11,520 situations. Well, any modern processor can check, and each of these calculations is fairly simple. It will happen in if it took a millisecond, that's a really slow processor. So 11,000 of those calculations, you're not taking terribly long to work out how long to sleep for. So if waking up is really expensive, and if you're not having to do so for, the rules have changed or the user's changed something, then maybe it's worth iterating over every minute. But seriously, that is how I would probably have implemented it if I really, really needed to work out how long to go for. Because anything else, the corner cases are going to be horrific. And you probably actually want to implement, I probably wouldn't implement all of the corner cases as tests for this case, for this approach, because I'm so confident that this would work that I don't need every one of the corner cases. I do a few of them. Whereas if I were trying to just use the rules and do it by saying, what time, Noda Time provides, please map this local date and time into 0, 1, or 2 instants in time, depending on what the time zone's doing at that point in time. It gives me that much, but the rest has to be down to the application and business rules. And it is just so painful that I wouldn't want to do it. It's just struck me that it's now just after 8 o'clock in Europe, London. So just to come back, my guess is that the people replying to me on Twitter hadn't thought about any of that. They hadn't thought a conversion to UTC makes no sense. This is a data type issue. And as I say, if you've got enough data types, if you start having to say, I don't have a date, so I'll just use January the 1st, or maybe the year 2000, January the 1st. If you find you're having to make up data, probably something is wrong with what data type you are using. This isn't railing against UTC as a concept or using UTC in sensible places. If it's a timestamp, this happened at this instant in time, that is logically an instant. UTC or some appropriate representation of an instant is absolutely fine. If you want to schedule in UTC, like I want my backups to happen at this time UTC every day as a cron job or something, that's absolutely fine, no problem. But be aware, if you are converting in any normal time zone from a local time to UTC, you are predicting the future. And unless you feel that you are particularly good at predicting the future, in which case do the lottery instead, I would avoid converting to UTC and thinking that is definitely no risks there. It may be that you evaluate the risk and say that's fine, but don't do it without being aware of it. And I would say, as a general rule, leaving dates and times to one side, if you store what the user told you, you can't lose any data, like short of storage failing. You can always normalize for the sake of efficiency and then normalize again later for the sake of efficiency. Do that as many times as you like. That's fine, because you've still got what the user told you. If what the user told you is no longer valid, if you've said we're meeting at 9:30 in the morning, and it turns out that the local time zone is going to skip from 9 till 10, then you can prompt the user saying, hey, that time no longer exists, or maybe it happens twice. What do you want me to do? If you have made an assumption earlier on and said, I'm absolutely sure that my assumption back then was right, with no real reason to be that confident, you can't prompt the user for more information. I'm going to skip over the next one of those slides. So top tip, have the concept of a clock. It's really easy to write an iClock interface if you're not using Noda Time. Obviously, use Noda Time. We supply iClock. We supply a fake clock so that you can use it in tests easily. But regard something that tells you the current instant in time as a dependency that should be injected. And if you do that, you'll no longer have to worry about, well, is this code going to work when it crosses into a different month, or when the time zone transitions happen? You can test what would happen if this were the case. Measuring the passage of time, things like what happens with thread.delay or awaiting things, that gets much more complicated. But if you've got date and time calculations, inject a clock and you can test things really easily. And that's the most important bits, I think. Tricky bits. Yeah, use a decent framework. Be aware of everything. Use date only and time only if you can. If you're forced to use the .NET framework representations, use what you're given. Be aware of time zone info, etc. Be aware that time zones do change their rules over time. And it is all feasible. With that, any final requests? Any questions? I've only run over by 5 minutes, which might be close to a personal record. Thank you all very, very much for listening to me waffle about time quite a lot. I do have one final slide, which is to be kind. I typically top and tail my slides with be kind slides, because I think it's probably the most important thing. If I can have any effect on you whatsoever, if I can make, I'm sure you're all lovely people, if I can make you a smidge kinder to the next person who irritates you and you just think, oh, Jon said be kind, I'll just pull my punch a little bit, whatever it is, we could all do with being a little bit more kind, and that would be amazing. Cool. Thank you very much, folks.